Alright, so the directions are to express as a single logarithm. So what does that mean? Well, there's kind of a hint in the next problem. If you look at this next problem, that's a single logarithm, right? So we want to take this three logarithmic expressions and make them one. All right, and we can do that with the log properties, which I've written down over here, the three log properties that we're going to use, although it's a little messy. Hopefully you can read them. The first thing I want to do here, I got three, and the parentheses are a hint. So look in the parentheses, and I say, well, that's the difference minus of two logarithms, the same base. So I'm going to use this guy right here at some point. At least I know I am going to use this guy at some point, right? But first, what's messing me up is you'll notice that in this formula right here that there are no coefficients for the logarithms. That means this coefficient of 1/2 is kind of messing me up. So first I got to use this property right here. Log base b of m to the n equals n log base b of m. What does that mean? Well, look where the n is. On one side of the equality, it's down here as a coefficient. On the other side, that's times. And the other side, it's the exponent. That means I'm allowed to move this 1/2 up. Often we go the other direction to simplify an exponential and we move it down. But in this case, if I'm asked to write as a single logarithm, then I want to do this. Y to the 1/2. See, I take that and just moved it up to the exponent, which I'm allowed to do. That has something to do with the inverse properties of the exponential function and the log function, okay? Now I can apply my difference, right? I can write those two as a single logarithm. That's the log base a of x over y to the 1/2 plus the log base a of z. So far so good. I've taken three logarithmic expressions and combined two of them, really, using my properties. So finally, I can use my third property. I see the sum of two logarithms with the same base is equal to the single logarithm, the log base a of the product of this guy and this guy. So just multiply them together. So that would be x times z over y to the 1/2. And I should have some equal sign in here. The given expression is equal to that, is equal to that, is equal to my answer. One single logarithm with positive exponents. Okay, good. So for the next one, we're doing the opposite here, right? We have the log base 8 of this whole thing raised to the third. So again, let me use a different color here. I can use this property first. I think I want to bring that exponent down. So that's equal to 3 times the log base 8 of this whole mess, y to the 4th. Square root of x, I'm going to write as x to the 1/2. And down here I got 3z squared. Okay. All right. So the next thing I see is a quotient. So I want to write this as, I want to use, of course, this property right here. Only we're going to go backwards. We're given the quotient. We're going to write a difference. So that's 3. Now I'm going to use some brackets here to organize my work. Log base 8. And then I should have a quotient. A difference. The first difference, part of that difference should be here, and then I'm going to minus log base 8 of the denominator. So log base 8, not a, log base 8 of the numerator, y to the 4th, x to the 1/2, minus log base 8 of 3z squared. Okay. Now, do we see what to do next? This is going to get a little lengthy, I believe. Let me give myself some more room. I now see that I have the log base 8 of a product here. That's a product. And the log base 8 of a product here. So I'm going to have to expand that. So it looks like we're going to at first have 4 logarithmic terms, right? 4 log base 8 terms. So let's see what we get when we do that. So that's equal to 3 times log base 8 of y to the 4th plus the log base 8 of x to the 1/2 minus the log base 8 of 3, let me use parentheses here, plus the log base 8 of z squared. Okay, that's applying this property right here. All right, and then, so that's expanded. Now, we have follow the directions and expand, but there's one more property that we could do. It's not really an expansion, but we could bring all these guys down if we wanted to, right? We could apply that first property and bring those guys down.